So for this next part, I'm going to disconnect a few batteries from the battery bank. So basically, I conclude that this battery is bad, at least compared to those new batteries, because with everything the same, the inverter would turn on from there, or the drill press would turn on from there, but it would not turn on from here. Even though it's still the same battery bank, as you can see, my connections are great. I use stainless steel bolts everywhere. These terminals are brass. No loss of amperage here. I'm using 2-gauge wire, so there's no voltage drop. Everything's connected properly, so it's safe. I'm pretty sure to conclude that this battery was unable to handle the load from the drill press or the air compressor, but over here it worked just fine. So with that being said, the next thing I want to test is if removing some of the batteries actually makes the system better. And I know that seems counterintuitive, and it certainly does for me, because even if we have some bad batteries, my reasoning is that they're at least helping. They're doing something. They're charging something, right? They're storing some charge, even though they're not great. You probably couldn't power up a car with it. You wouldn't be able to crank an engine with it, but it's holding some charge, and a bunch of weak batteries together makes a big strong one. So that's my reasoning. However, I've been told by a few people, and I also been told by artificial intelligence, AI, that bad batteries in a battery bank will actually make it worse. So it actually said that it's terrible, it's bad, it actually said terrible to have bad batteries in the system, because they'll actually act as resistors and they'll damage the good batteries, and the system won't work properly. It'll actually drain power. It'll work against itself. So we're about to determine that. So right here, as you can see, I've got basically 3 battery banks. These are the good batteries. These are big, newer AGM batteries. These batteries on this middle bank, they are reasonably good batteries. I did test them. The testing of batteries is a whole different subject, but they worked okay. And then over here, you got the batteries that are supposedly bad. And there's another battery disconnect there. So what I'm gonna do first is this bank is connected to the this cable is connected. These cables, the ones from the charge controllers, are connected to this middle bank. So I'm just gonna disconnect this bank first so that it'll keep charging, because if I disconnect this bank, then I won't be getting the input from the charge controllers, and that won't make the test valid, because we won't be getting any solar power. So I've used this little breaker bar so that I can turn on the air compressor remotely. So let's see what happens. So these, as you can see, these are pretty big batteries. They're not little batteries. They're the biggest. This one is 800 CCA, 180 amp hours. So let's disconnect them. Well, let's just see if the compressor will turn on again. Just make sure everything's the same. So here it could turn on quite easily, no hesitation. So let's disconnect the battery bank. Let's see what happens now. It's still turned on, but as you can hear, it did beep a little. And it's not turning on anymore. Staying on. If I try to turn it on, nothing. Okay, so now I'm actually going to leave this on. Let's see what happens when I connect this battery bank again. The beeping stopped and the compressor turned on, as you can hear. It'll probably turn off if I turn this off. Well, it might not because it's already running, so. But anyways, I've just proven that artificial intelligence is absolutely wrong. Because even though these batteries aren't the greatest, they're helping. At least in terms, I don't know if they're shortening the lifespan of the other batteries, but it's making the system usable. Without these bad batteries, the system is unusable. So let's try disconnecting this battery bank now. So now I just have the good batteries connected. I'm not getting the power from the solar system yet, so let's just move the cables over. And hard doing this with one hand. So we should still be connected to the solar system, but now, oops, obviously these things are shit, but it should. They're disconnected from these two batteries, and once I turn this off, it's already off. We're disconnected from all the other batteries, except for this bank. This bank is still connected, so we'll see what that does. Turning it on again. It did turn on. Let's try turning it on again. It's struggling. It's obviously struggling a bit more. Let's do that test again. But it's not as bad as when I disconnected this bank. So it certainly seems that this bank is not as good as this one. Did I say that right? But anyways, voltage has also dropped quite a bit more now, 12.2 volts. Turn this off, and now let's do exactly what ChatGPT said. I'm just going to disconnect the other battery bank as well, so that now we're just running from the two good batteries along with this one. So it's almost an accurate test because I still have this battery, which is probably not so good, but it's just a big deal trying to disconnect the inverter and the charge controller wires from it. So we'll just leave that one and let's see what happens. So 2 good batteries with maybe just one that's not good. Wasn't really expecting this to work. That's 1, 2. It'll turn on the third time. And it didn't turn on the third time. After it just struggles a little bit more. Let's see what kind of numbers we're getting. So obviously the solar charge controller is handling most of the load, but what I think happens is at peak current, so when you turn something on, there's a surge, right? Once just after a second after it starts after it's actually running, then you have and the amperage draw reduces significantly because it's already running. An analogy is you can keep pushing an elephant that's moving on the ice. Imagine you're on a skating rink on the ice. The elephant is sliding. It's easier to keep it moving, to push it while it's moving, than to try to get it to move when it's stopped. Right? So anyways, what is definitely happening is the solar charge controller. It can't charge the battery fast enough when it turns on. So I think what happens is once I turn the motor on, it kind of drains the battery real quick, but right away or just after a second, the solar charge controller recharges the battery and keeps the compressor running. I've had the compressor running for 15 minutes that way, and the battery voltage was still good. So this system is workable. It's usable. It's definitely working. But with the bad batteries, it works a lot better.